And number 13, we're trying to find the critical value associated with a certain level of confidence, and we'll be creating a confidence interval here. And notice we'll be using the t-distribution, and that's because we have to use the t-distribution anytime we don't know the population standard deviation. And this is discussed in 6.2. And here's a visual of what we're trying to do. If we were looking for a 95% confidence interval, we would look for the critical values where 95% of the data lies in between those two values, and then the other 5% is split between the two tails. And so for this example I'm going to work out, we are looking for the 95% confidence interval, and we always need to know the sample size when dealing with the t-distribution, because the t-distribution relies on something called degrees of freedom, which is always one less than the sample size. In Excel, we can use either one of these formulas. The .2t stands for two tails, so we're using the t-distribution, and we're going to find the critical value associated with 5% split between the two tails. So we got the 5% because our confidence level was 95%. We want 95% between the critical values and then 5% in the two tails. And then the next thing you enter is the degrees of freedom, which is always one less than the sample size. And so that's the critical value you want. This formula in Excel just gives you the left-hand tail. So you would want to split that 5% between both the tails. So there's 2.5% in the left-hand tail and also 2.5% in the right-hand tail. So with this formula, we would need to enter 0.025 as opposed to 5%. But the degrees of freedom is the same, one less than the sample size, and we get the same result. It just is giving us the left-hand critical value here, which is negative. The right-hand one would always be the positive. And you can just enter the positive one there for the answer. 14 is similar to 13. We're looking for the critical value in the t-distribution. Our confidence level is 80%, and we have our sample size. So in Excel, I can use this formula here. The 2t stands for two tails. So if I have 80% confidence, there's going to be 80% of the distribution in between the critical values, which leaves 20% to be in the two tails. And since I'm using the 2t formula, I can just enter the 0.2 for 20%. I don't have to worry about splitting it between the two tails. And the degrees of freedom is always one less than the sample size. So when you enter that, you get your critical value that you need. And number 15, we're actually going to be constructing a confidence interval. We'll need to use the t-distribution because we do not know the population standard deviation. We're told the sample standard deviation, the sample mean, and the sample size, which we'll need, and we'll be constructing, in this case, a 95% confidence interval. So here's the formula we're going to use to get the margin of error, and we have to use the t-distribution because we do not know the population standard deviation. We just know the sample standard deviation. The formula asks for our alpha, which is 100% minus our confidence level, so in this case 5%, as a decimal, 0.05. Then you want the sample standard deviation, and then the sample size. And Excel will give you back the margin of error. To construct the confidence interval, the sample mean is always in the very center of the confidence interval. You take the sample mean and add the margin of error to get the upper bound. You take the sample mean and subtract the margin of error to get the lower bound. So we are 95% confident that the population mean lies somewhere between these two numbers. For 16, we'll be constructing a confidence interval. And our situation here is we have a sample of 10 cell phones. We'll need to know the sample size. And in that sample, we have the mean of the sample and the standard deviation of the sample. And we're going to need to use the t-distribution because we do not know the population standard deviation. And we'll be constructing a 90% confidence interval for the population mean. So here's our information. In Excel, we use this formula, confidence.t, for our t-distribution. And this will give us back the margin of error. So our alpha is 10%, 100% minus the confidence level. Then enter the sample standard deviation and then the sample size. And you get your margin of error. To construct the confidence interval, sample mean is always right in the middle of the confidence interval. Take the sample mean and add the margin of error to get the upper bound. Take the sample mean, subtract the margin of error to get the lower bound. And then to interpret the results, what we have is that we are 90% confident that the population mean for the full retail price of a cell phone is in between the endpoints of our confidence interval. The mean price is somewhere between these dollar amounts. And number 17, we're going to decide whether to use the normal or the t-distribution. We'll be making a 99% confidence interval for our population mean. And here's the information about our sample. The size is given, the mean of the sample is given, and the standard deviation of the sample is given. Now, nowhere does it say what the population standard deviation is, and because of that, we have to use the t-distribution instead of the normal distribution. In 6.2, the decision-making process for using the t-distribution is also listed right here. The population standard deviation is not known, but we also have to have a random sample, and either the population's normally distributed, which we were not told in this problem, or the sample size is greater than 30. And in this case, we do have a sample that is larger than 30. And so then we're going to rely on the central limit theorem to help us construct these confidence intervals. So here's the information from the problem. This formula in Excel will give us the margin of error. 99% confidence level means 1% in the tails, so alpha is 0.01. The standard deviation for our sample, you enter next. And then the sample size is your last argument. And that gives you the margin of error. Our sample mean is always in the very middle of our confidence interval. The sample mean plus the margin of error is the upper bound. The sample mean minus the margin of error is the lower bound. So interpreting that confidence interval we just created, we can say with 99% confidence that the population mean is in between the upper and lower bounds of our confidence interval. It's somewhere between these numbers.